Alright, continuing with the section 4.1 notes, we're now going to look at the three possible outcomes that can occur when you're looking at solving a system of equations graphically. So our first example, we have the system 2x plus y equals -5 and -x plus 3y equals 6. To solve this graphically, as we just looked at that camera example in the last video, we really want to see, well, if we were to graph these two lines, where do they cross? Where is that point of intersection? And that point of intersection will give us the ordered pair that is the solution for these two equations. So rather than trying to guess the ordered pair, we can get a more direct answer by actually just graphing the two lines. The first equation, 2x plus y equals -5, we can start with that, and really the best way, maybe the easiest way to graph these two equations would be to get them into y equals form, into the slope-intercept form, and then once we are in slope-intercept form, graphing them, we can graph the equations using the slope and the intercept. So let's manipulate these equations a little bit, starting with 2x plus y equals -5. If we want to solve this equation for y, we want to start by getting the x term on the other side of the y term. So we would have to subtract away a 2x from both sides. Okay. This will cancel out the x terms here. And we are left with y equals, you could write it as -5 minus 2x. Some people are sticklers, always want to look at it with the x term first. -2x minus 5, either way works, as long as you remember what represents your slope and which represents your intercept. So if there's one equation, looking at that equation, the constant term, the number by itself, -5, that's going to represent our y-intercept. So we come down here at -5 on our y-axis. Remember, this is our x-axis, y-axis. So there's 1 point for that line. And then we need to use the slope, the -2, to move from that point. So if you recall, the slope of -2, okay, our m value, it's not a fraction, but we can make it a fraction by putting it over 1, and that tells us our movement from the point we already drew in is going to be down 2 to the right 1. So there's our y-intercept. We have to move down 2, 1, 2 over 1, down 2 over 1. We're out of space making points that way, so if we want to make a points to the left, we'd have to go up 2 over to the left 1, up 2 to the left 1. You can see all these points are going to lie on the same line. So moving the opposite, up 2 to the left 1. And I would keep making points because we don't know where the two lines are going to cross. So you want to make a decent amount of points. Hopefully one of those points are going to be where the two lines do cross each other. So then coming through these points I drew in, I'll now draw our line representing the entire equation. Okay. So there's our first equation graphed. Now let's take a look at the other. We have -x plus 3y equals 6. Okay. First step here, we'd want to add x to both sides of the equation in order to get the y term by itself. So adding an x on the left side of that equation is going to cancel the x terms, leaving us with 3y equals 6 plus x. And then last step, to get the x term completely, or the y term, y completely by itself, we have to divide by the coefficient of y, the 3. But remember, when we do this, we have to divide every single term on both sides by 3. So this cancels out the 3's, so we do get our y by itself. Looking at our first part here, the 6 divided by 3 would give us 2. And then, well, we don't really have a number attached to x, so you have to remember there's a hidden coefficient of 1. So we'd have 1 over 3, or 1/3 x. Alright, so now we have our second equation. We can graph this, starting with our y-intercept. Now I rearranged the order of the terms. You just have to keep in mind the number that's by itself, the constant term, the 2, that's going to be our y-intercept. So we start on our y-axis at the point 0, 2. And now we use our slope to move. Our slope of 1/3, because that's the number attached to x. That is going to tell us our movement will be up 1 and to the right 3. Positive slope, so you're always going to be moving up and to the right when you have a positive slope. Up 1 to the right 3 puts us here. We could make as many points to the right as we want, but that's not going to help us because we want to see where these two lines cross. So we're going to have to move down 1 and to the left 3 to see where they cross, and we actually see right there. Both lines will hit that point. And we can go maybe one more, down 1 to the left 3, so we get a better picture of the line. Okay. So just draw a line in to connect these points. Alright, so now we have both lines drawn in. We can clearly see from this graph where they cross. That point there is the ordered pair 1, 2, 3. So -3 for the x-coordinate, +1 for the y-coordinate, because we're moving 3 to the left and up 1. So there's our solution, -3, 1. And this example, so this represents one of the possible outcomes. So when we have one solution, like we just found in this example, when we come up with a solution, we say the system is consistent. We say it's a consistent system. And because there is one solution, we also say it's independent. This is just terminology you're going to have to kind of memorize. Okay. So one solution, how we classify that then, that system is we say it's consistent and independent. Alright, so that's one of the 3 possible outcomes. Let's take a look at the other 2 in the next 2 examples. If you think about how lines could possibly be drawn, you can maybe already kind of think about what these other 2 outcomes might be. Alright, so now we have the system -3y equals -4x plus 9, and 6y equals 8x plus 24. So same idea, we're trying to graph these to solve. So in order to graph them, we're going to want to solve them for y, get them into y equals form, slope-intercept form, and then graph. So let's start with our first equation. We have -3y equals -4x plus 9. This is only going to require one step to solve, and that's dividing by our coefficient of -3. That will get us y by itself, but we have to divide by -3 from each of our terms in the equation. And this gives us, canceling out the -3's, we have y equals, well, a negative over a negative, and a fraction will always, the negatives will cancel out. This will give us a positive 4/3 x, and we can't reduce that fraction, so nothing else to do there. And then 9 divided by a -3 is going to give us a -3. That will reduce to a whole number. Okay. So there's our first equation. We can go ahead and graph that now. Our constant term, the number by itself, is -3. So our y-intercept is going to be down here at -3. Okay, again, y-axis, x-axis. And now we want to use our slope to move. Okay. We have this slope of 4/3. Okay. Positive 4/3. So from point to point, we're going to be moving up 4 and to the right 3. So up 1, 2, 3, 4, to the right 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And that'll be good enough in this example. So you'll see here. Actually, maybe I'll make one to the left. So down 1, 2, 3, 4, to the left 1, 2, 3. You know if you're moving right or moving correctly because your points will all lie on the same line. If they don't, and you end up getting some kind of crooked line, you know you messed something up with your movement when you used your slope. Alright, so there's our green equation, our first equation. Let's solve the next one. 6y equals 8x plus 24. Okay. Once again, this is just going to require one step. Divide everything by the y coefficient 6. Which will cancel out the 6's, get y by itself. And we want to reduce any fractions, if possible. So it might not look obvious at first, but now if we reduce the slope, the numbers attached to x, 8 over 6 will actually reduce to 4/3. So giving us 4/3 x. And then 24 divided by 6 will reduce to a whole number. That will give us 4. Okay. If you remember or forget how to reduce fractions, okay, 2 will go into 8 and into 6 because they're both even. 2 goes into 8 4 times. 2 goes into 6 3 times. So that's how I got 4/3. Alright, so there's our second equation. Y equals 4/3 x plus 4. Maybe make a little note to remind yourself you do always want to reduce if you have a fraction slope. Because we could use that slope as 8 over 6 and move up 8 to the right 6, but it would be easier to move it as up 4 to the right 3. So let's make this graph. Our y-intercept is going to be at 4, because that's the constant term. And then let's use our slope to move. Again, it's 4/3, so we have the same slope as we did in the first equation. So moving up 4, 1, 2, 3, 4 to the right 3, 1, 2, 3. And then let's get a point on the left side, down 4, 1, 2, 3, 4 to the left 3, 1, 2, 3. And as this graph starts to take shape, we can kind of see these lines actually aren't going to cross each other. Okay. Lines like this we call parallel. And the reason these lines are parallel is the fact that they have the same slope is what's going to cause those parallel lines every time. So in this one, because we had the same slope, which was 4/3, okay, that slope is what tells you how to move from point to point. So if it's two lines have the same slope, they're going to move the same way as you go from point to point. So they're going to move the same way, they just start at a different spot, they're never going to cross each other. They're going to be that same kind of steepness. So when you have the same slope, you're always going to get some parallel lines. Okay. So if we're looking for the point of intersection and they never intersect, we say we have no solution. Which, if you recall, we'll see written as the null set. Circle with a line through it. And with this one, our conclusion is that our system is inconsistent, but it's still independent. Okay? So inconsistent, there are no solutions, and so we say it's inconsistent, but they are still two independent lines. Up here, in the first example, they were two independent lines, but there was a solution, so it was consistent. No solution, inconsistent, but still two independent lines, two different lines. Alright, so that shows us the second possibility, and there's a third, which may not be as easy to think of when you have two lines, but we'll see what's going to happen here in this last possibility. Alright, so we have our two equations to make up our system here. One more time, we want to solve both of these for y, and so we can then graph them. So our first equation, bring this up, 2x minus y equals 3. Solving this for y, get the x term on the other side, so subtract 2x, subtract 2x. This leaves us with a negative y on the left-hand side and a negative 2x plus 3 on the right-hand side. Or 3 minus 2x, however you want to write that. Okay. X terms cancel out. Now, to get y by itself, because it's technically not y by itself yet, because there is a negative attached to it, you can think of that negative y, there's the hidden coefficient of a negative 1 there then. So in order to get y by itself, we have to divide everything by a negative 1. Because dividing by negative 1 just really is going to cancel out a negative, or change the sign of whatever you have. So that gets us the y by itself here. Makes it a positive y. Makes this negative 2x become a positive 2x. It makes a positive 3 become a minus 3. Okay. So equation 1. We can graph is minus 3 is a constant term. There's our y-intercept, 1, 2, 3. On our y-axis, there's our x-axis. And then using our slope to move, our slope is 2. So we make that a fraction, putting it over 1. And to move from point to point, we're going to go up 2 to the right 1. So up 1, 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and maybe make 1 point to the left, down 2 to the left 1. That should be good. Equation 1's been graphed. Let's look at equation 2. 6x minus 3y equals 9. We want to get rid of the x term, so subtract 6x from both sides. This leaves us with a negative 3y on the left and negative 6x plus 9 on the right. So we can cancel out our x terms. Last step, divide by y's coefficient, which is going to be negative 3. So dividing everything by negative 3, negative 3's cancel, gets us y by itself, and we end up having y equals negative 6 divided by negative 3 gives us a positive 2, so 2x. 9 divided by negative 3 gives us minus 3. So we actually have the same exact equation. Didn't look like the exact same equation at the beginning, but when we solve it for y, getting it into slope-intercept form, we see we actually do get the exact same equation. So you don't exactly have to regraph the same line. We know it is going to be this same line, just kind of right on top of the other. So kind of drawing on top of my blue line, just kind of redraw a purple line. Although really, you really wouldn't see two lines because they are right on top of each other. So what does this mean as far as our solution? Well, let's talk about that. First of all, we have the same line. And remember, when our solution is going to be where these two lines cross each other. Well, these two lines cross each other everywhere on the line. Every single ordered pair, every point on this line is technically going to be considered a solution. So there's tons of solutions. There's an unlimited amount of solutions. So we would say there's infinite solutions to this system. Okay? And we classify that as there is at least one solution. There's infinity solutions, but since there is at least one, we say it is consistent. But it's not independent anymore because they're not two independent lines. They're the same line. So instead of independent, this is going to be the case where we would say the system is dependent. So consistent tells you that there's at least one solution. Dependent tells you that the solutions are all going to be the same, whatever's on that line, because we're sharing the same line. And those are 3 possible outcomes when we are solving a system graphically. In the next videos, we'll look at our other methods to solve systems.